Okay, so now sometimes we don't want to add the values. Okay, so we're adding right here this neighborhood prediction value. Sometimes we want to subtract values, and I bet you can probably guess when we want to add and when we want to subtract. It depends upon whether we have a positive or a negative correlation. So really, we don't care about the absolute values that are in this table. We would if we were doing 2 or 3 or 4 neighbors, but since we're just doing one neighbor, all we care about is whether the values are positive or negative. So you could really just replace this with either a minus or a plus in all these values here, and it wouldn't make a difference to us for these purposes. Okay, so now let's consider another example. Let's try user B and movie 4. So with user B and movie 4, we have a baseline value of 3.50, and that's in the test set. So now this is a case where we couldn't actually add the error because we don't know what the error is. So we have 3.50. Okay, now we look at 4. 4's neighbor is 2, so 4 also uses 2 as its nearest neighbor. So the question is now, has B rated movie 2? And the answer is yes, B has rated movie 2, and that is part of the training set. Okay, so we can use this value, and this value is 0.17. So what that's indicating to us is that the predictor was too low by 0.17 for this rating of B for movie 2. Now here's the kicker. 2 and 4 have a negative correlation. Okay, so since the predictor was too low for movie 2, we're going to think that it was probably too high for movie 4. So rather than adding this value of 0.17, we're going to subtract the 0.17 out. Okay, so we're going to subtract the 0.17 and say, since this is indicating it was too low, it was probably too high for number 4. Okay, and statistically speaking, we would say that probabilistically it is, the probability is great that it's going to be higher. That's the idea here. So then we subtract out 0.17, and we get 3.33. So this is for C5. This is for B4. So now we can write out just a simple general equation here is that the neighborhood predictor is going to be the baseline plus or minus the error for the neighbor. And we add it if it's a positive correlation, and we subtract if it's a negative correlation. That's it. That's all we need. We just need these 3 tables, and then we can do all these calculations. So we can try another example really quick, because I just want to illustrate the fact that here with C5, for instance, we know that the value is 3 over here. So we're going from 2.60 to 3.27, which is overshooting the value, but it's still closer, right? 3.27 is closer to 3 than 2.60 is. And the same thing with B4. If we look at B and 4, the real value is 3, and B4 was 3.50 before, and now we're subtracting and getting 3.33, so we are getting closer. But in general, we're not always going to get closer, and we just hope that overall the RMSE gets lower. So sometimes it's going to be a mistake. It's going to go in the wrong direction, for instance. So as an example of that, let's take user F's rating of movie 5. So this is 0.4 right here, and 3.85 is already pretty close to 0.4. But for F5, we said we would have 3.85. And then if we look at 5's nearest neighbor again, we said was 2. So then we go into the table for 2. F has rated 2. And there are positive correlations, so we would actually end up subtracting. We add the error here, which is a negative value, which means that we really subtract here because it's saying the predictor was too high. Then we get something like 3.27. And 3.27 is clearly in the wrong direction. 3.85 is closer, so this is getting farther away. And so it's not always going to give us better, but there's nothing we can do about that. We just hope that overall it gets better. And the final point is that if we get a time where the neighbor has not rated the movie, then we just don't use it. Like we know, for instance, that 5's neighbor is 2. I'll take that example again. So if we were trying to do for D5, right, and we have this value here, we could not use D2, right, because even though 2 is the neighbor, so we would want to see what D had rated movie 2 in order to augment the prediction for 5. But since that's part of the test set, we couldn't use that, so we would just keep the baseline predictor the way it was instead of trying to add anything on at all.